So thank you very much for joining us. And like I said, the context, it's basically we have the data science person who's an expert in this area, and I'm hoping that through the Fireside chat, we can actually learn about some of the aspects that users of these technologies would have to know. And I think I would like to first kick us off with understanding some of the behavioral aspects, or how should managers go about using data science? And I have to say that I'm partially motivated by this question because of my research. And my research is largely looking at how do managers in the workspace use machine learning tools. And one of the companies that I worked with, this invested a huge amount of money on machine learning because their managers, senior managers heard lots of great things about it. They invested millions of dollars, got the machine learning tool into the stores, and the users, which were the category managers in this retail organization, completely rejected it, right? So they basically overrode 70% of the recommendations coming from machine learning. So as we think about this data science, what are some of the things that managers need to keep in mind from a behavioral aspect?
No, this is great. I love this question. And by the way, I'm a data scientist, but I'm also we can get as advanced as we want with data science and technology. AV is always going to be the problem. No, I think we can feed off each other, because I've been a practicing data scientist for a long time. I'm also a bit of a skeptic, so we should try not to amplify each other too much. I'm going to back up a little bit. I think there are kind of 2 points I want to make about this question. It's an excellent question. Oh, is this better? Can you hear me okay? Can you hear me in the back? No? How about now? Is this okay? Great. Okay, thank you. I'm going to back up and make 2 points about what managers should know about this stuff. I have a slightly different metaphor. I like the car metaphor. The one I used when I was at Deloitte, when I would be speaking with clients, is pretend you're building a house and you're working with an architect to build your own house. Now, would you like it if the architect just went off on his own and just imagine what he would like to live in and what his needs are? Or my family is this size, this is probably what that person would like. Or would you rather have an architect who actually talks to you and understands what needs you have, and then from that decides to build your house? So I always thought that was a pretty good metaphor. You can think of a big aspect of data science as being a design challenge. Now, my own background is I started off in insurance. That's where I got a lot of my early experience. So when I joined Deloitte, I don't know how many of you were even alive back then, I was part of a practice that we actually pioneered something. It was actually a very exciting thing. Before we innovated our product, when a business wanted to buy insurance in the US to say just insure themselves against some kind of liability or an injured worker or something like that, an insurance company would go out and they would sort of inspect the business. And it's kind of like a doctor making a medical decision. It's like, okay, yeah, this looks pretty good. This manager looks pretty responsible, blah, blah, blah. What we learned was that if we just built a predictive algorithm to help that underwriter make the decision, our client companies could save millions of dollars a year. They'd shave loss ratio points off their bottom line. We basically stumbled onto an inefficient market. There's a lot of publicly available information about these insurance risks that weren't systematically being used to price those risks and decide whether to write insurance. It was like a pricing underwriting kind of decision. So huge hit. Okay, but a big part of our decision was very detailed design issues about what data set are we going to construct to build the algorithm. And we were just talking before about this motto that all models are wrong, some are useful. Well, the more we go from classical statistics to what's called machine learning, it becomes very parasitic on data. You can think of a machine learning model as being a really elaborate summarization of a big data set. And so if you've got a data set and it's just slightly off, right? You think you're predicting A, but you're really predicting B. You could really get into trouble with that, or if you go too far back in time, but your business has changed a little bit. So a lot of data scientists don't really understand that, or there might be a mismatch. The end user might understand something that the data scientist doesn't understand, and vice versa. So very often, what happens is the people that understand the world don't understand the math, and the people that understand the math don't understand the world. Now, I'll give you an example, kind of from my own domain of insurance. There's a company called United Healthcare, just been in the news recently. If you heard about this news from New York City, Well, they built an algorithm many years ago to essentially target certain health insureds for concierge health service. You know, there's this kind of fact in health insurance that the worst 5% of the risks account for 60% of the utilization. So if you can target those people with an algorithm and say, hey, you know, we're going to give you these services. Don't go to the emergency room when you're sick. Call this number. You're going to save everybody money. They'll get better service. They won't clog the emergency rooms. It's a very good idea. So it's a very expensive intervention, so you want to target it using analytics. It's a smart idea, right? What happened was the data scientists decided to predict healthcare expenditure. And they figured, well, the people that have had the most healthcare expenditure in the past, they will need the most in the future. Makes sense, right? Well, what happened was they built the algorithm, and it turned out that this is a US application. If you're African American, you essentially had to be twice as sick to get that health benefit as if you're non-African American, if you're white, for example. The reason is, this is very subtle. The reason is that in the US, African Americans systematically have less access to health care than whites. So if you're using healthcare expenditure as the target variable, right, it will be systematically biased against African Americans. So that's like an example of you think you're predicting A, but you're really predicting B, and it gets into trouble. So we spent a huge amount of time in our practice early on getting those kinds of decisions right. We would literally have these boring conversations with our client, and we'd write a memo about how we're going to design the data set, how we're going to design the algorithm. Are we going to use a neural net model or a regression model, whatever? And we'd iterate that with the clients and go back and forth. And I swear, this is like the most common sense thing in the world to do, and nobody does it. I think it's, again, I'm cynical. I think that in the last 10, 15 years, there's been so much hype around data science that people think that if you've got the better algorithm, you've got deep learning instead of support vector machines or whatever it is, that's going to save the day. No, you need to get the data set right. So I call that the first mile problem, getting the data set right. And then now I'm going to finally get to your question. What I call the last mile problem is that if you're in business, you don't care about the output of an algorithm, do you? Ultimately, you do, but only because you want that algorithmic output to give you a better outcome. So I call that the last mile problem. So the first mile problem is you got to get the data set right. You got to construct that, you got to design it. And often if you're a data scientist, you need to talk to the domain expert or the institutional expert, the data expert, whatever it is. So as a manager, you want to make sure to make those connections between the data scientists and the end users and the domain experts. You want to kind of create the right team. But then you have folding that algorithm into human decision makings or human behavior. That's a real challenge too. That's what I call the last mile problem. I'm sorry, I'm just going to make one last story and then maybe we're out of time already. I mentioned that our practice pioneered the use of predictive algorithms to help insurance underwriters make pricing and risk decisions, right? Underwriting and pricing decisions. This is very successful, and so a smaller workers' compensation insurance carrier got word, and they wanted us to build a model for them. Now they were small, so they didn't have a lot of data to give us, so we were a little nervous about that. We literally had conversations saying, well, we don't want to sell snake oil, so should we even take this client? But we decided to give it a go. And they also said, just build the model, we'll do the rest. So they wanted to pay us as little as possible, they just didn't have a lot of money. And so we built the model, we built this predictive algorithm, and we heard back from them 6 months later. And they said, congratulations guys, this is just as predictive as we all hoped it would be. And we were like, yes, good, we're relieved. And then they continued saying, but we lost money with it. And the reason was their underwriters were systematically using the algorithms, sorry for this choice now, they were using these algorithms to give discounts to good risks, but they didn't commensurately surcharge bad risks. So they actually took a good algorithm they paid us to build and that they've verified worked well in the field and systematically used it to collect less revenue. That was a real wake-up moment for me. I went on to call this artificial stupidity. You know, when a user uses an algorithm and actually makes a worse decision than he or she would have made otherwise. A few years ago, I was actually telling this story to a boot camp that I was teaching. I was regaling the class with a story. I was in Atlanta, Georgia, in the US. And after the boot camp was over, I got into an Uber to go up to a neighborhood called Midtown to get dinner. Now in Atlanta, going from the Deloitte office to Midtown was one straight shot up Peachtree Street. So any local person would know this. And the cab driver, the Uber driver, got lost along the way. And the reason was that he was following the signals from a GPS app, and the signals were distorted by all the high-rise buildings around. And then it occurred to me, wait a minute, this is artificial stupidity too. This is the exact same thing. A guy who actually knows his way to Midtown is following this algorithm and doing something really dumb with it. That's also artificial stupidity. There's actually a Wikipedia page, if you look it up, called Death by GPS. And there are literally people that get killed because they will drive over a bridge that collapsed, or they will, drive into Death Valley in the middle of the summer. They basically are smart people, but they lose their common sense and situational awareness. So I think of death by GPS as kind of like a metaphor for what you don't want to have happen. You don't want to implement these algorithms and have decision makers cede too much decision-making authority to the algorithms. Because the algorithms are good at what they do. They're good at some things that humans are bad at. But we always forget that humans are good at an awful lot of things that algorithms are bad at. So kind of getting that balance and getting the algorithms to work well, the humans, that's an art, not a science. But the good news is that it will keep you in business if that's the kind of thing you're working in. You have to kind of muddle through it. I hope that was helpful.
Actually, you said a few different things that were actually very useful, and I want to go over a couple of those things. I mean, the first one on the ethical aspects of algorithm, which I will come to hopefully later. The other one, which you mentioned very interestingly, this is something that I think about as a dean, which is like, how much of data science should I teach the MBA students? Or more broadly, how much data science should a manager know?
Right.
And earlier, before my PhD, I used to work in the supply chain industry, and that was the time, early 2000s, when this new technology came up. There was ERP, and then there was supply chain technology. And when we would go and sell these technologies to organizations, it wasn't essential for the CIOs or the CTOs to understand the nitty-gritty of the software, right? So basically they will, you need to make the ROI case, and then they'll say, okay, now go deal with the planners. And essentially, if the planners are okay, their test cases get okay, then implement it.
Yep.
But somehow with this data science, I feel that this hands-off approach does not work.
Yep.
It looks like that the training needs to happen all the way from the top. And the CEOs, the CXOs, everybody has to be trained on at least some fundamentals on data science, on AI, and part of the reason, there are several reasons for it. I think one reason is that if you don't know how to wield this weapon, you might actually end up shooting the wrong person or shooting off in the wrong direction for a long time, right? Because your reliance on the models seem to be increasing tremendously with the use of these sophisticated technologies like machine learning, for example, which is just a black box. Nobody knows what happens inside. It just comes up with the output. So how should managers deal with this? Do you see a convergence where managers need to know data science and data science folks have to know management, or
Yeah, in a way I kind of do, but at a very high level. There's a science fiction author, H.G. Wells. He wrote The Time Machine. He wrote 100 years ago. He was a science fiction writer, but he got this right. He said that one day a knowledge of statistics will be as important for efficient citizenship as the ability to read and write. So I'm a liberal arts guy. I think that statistics and data science and AI should be taught as a liberal art. So at kind of a high level, just like a conceptual understanding.
As a statistics professor, I know I second H.G. Wells.
No, I seriously believe that. But no, here's a story from my back pages. Like when I was building one of my workers' comp models, again, way back in the day, I was building for the California Workers' Comp State Fund. It's the largest workers' compensation insurance carrier in the world. And we actually went on a road show, and we're introducing, this was not so much the managers, but the decision makers, but analogous kind of thing. We were actually teaching the underwriters about these algorithms. And this was not me. This was like the senior underwriter at our client side. She said something. I think she must have been a former teacher because she was so smart. She explained things so well. And at one point, she just said in this very direct way, "Just remember, guys, all these things can do is weigh the information that they're presented with. If it has 20 variables, I'm paraphrasing, but if it has 20 variables, but variables 21, 22, and 23, and those are important, and maybe variable 4 is a mismeasurement. Maybe it got the credit score wrong or something like that. Then guess what you should do? You should override it." And then somebody in the room, it was about this size, so a huge room of people, somebody in the room blurted out, "Oh, I get it. It's a tool, not a rule." And everybody said, yeah, it's a tool, not a rule. They gave them this mantra. You know what I mean? And now, there's a famous book on design called The Design of Everyday Things. And the guy who wrote it is a psychologist. And he said that one of the most important design principles for any technology is that the user should have a good mental model of the technology. So I don't have to know how the refrigerator works. I don't need to understand thermodynamics, but I at least need to understand what these knobs do. You know, it's not like this is for the freezer, this is for a refrigerator. One is about the overall heat, amount of heat being taken, the other distributes the heat, or something like that. Similarly with algorithms, you have to just know kind of at a high level this premise that they're parasitic on data. There can be data drift, there can be target variable leakage, there can be label bias. See, I'm saying all these technical things right now, but at a high level, like that story I told about you thought you're predicting health status, but you're really predicting expenditure, and that can lead to a bias. People understand stories like that. So I think what we should take is teach every single pitfall and just tell a few stories like this. Give people a mental model.
Great, and just to have a balanced conversation and not just sound like we're all completely skeptical about data science. So what are maybe let's talk about some of the pros, just to throw it in there. Are there any success stories that you would like to share with us?
Yeah, well, I mean, the fact, the application we did around underwriting was hugely influential. I mean, it did save all of our clients millions of dollars a year, and it became an industry standard at one point. So that you can't argue with that. And we did this, by the way, before there's any hype around data science. So it really can work if you take this kind of design-led approach. I think the reason, here's another kind of general thing to take away from your manager. Look for things that algorithms are good at, that humans are bad at, but don't let that crowd out the things that humans are good at. Okay, don't see too much control. So in the application we did, if you studied a little bit of behavioral economics, you know that humans have biased cognition, right? When I first was explaining these algorithms to our clients, I actually said something that was false to them. I didn't realize it at the time, but I said, when you guys make a decision, you're building a little regression model in your head. You're weighing these risk factors together. And we're building an algorithm that can just, instead of weigh 5 risk factors, we can weigh 20 risk factors. And we can just do it more accurately. That wasn't quite right, actually. That was a little bit of a noble lie. Because actually, when someone makes a decision and they come to judgment, they don't build a little statistical model in their head. What they do is they use rules of thumb that are called heuristics, from the Greek word eureka, which means I found it. And those heuristics are systematically biased. So this is the famous Thinking Fast and Slow by Daniel Kahneman and the work of Kahneman and Tversky. So for example, if an underwriter, and when I say underwriter, that's what I'm familiar with. Just think judge, think hiring manager, think doctor making a diagnosis, think police officer deciding, is this person the right suspect, and so on and so on. 90% of business is about making decisions. So these are very portable, observations. But no, so when somebody makes a decision, they might look at this risk, and they might say, "Ooh, God! Last time I wrote I wrote a policy for a restaurant that looked like that. There's a big grease fire. Well, I'm not going to do that again." That person is using the availability heuristic, which means the easier a scenario comes to mind, the higher probability you ascribe to that scenario. In statistical terms, that would be like giving that beta parameter in the regression model a weight of 0.4 instead of 0.004. So you're not really building a regression model in your head. You're really using these heuristics that are biased. So just doing simple things to kind of alleviate that can be worth a lot of money. And again, there's so much hype around machine learning these days, and machine learning is tightly connected with this idea of automation, that there's a danger that people lose sight of the fact that what we're really talking about very, very often in the business world is using algorithms to improve human decision making.
Speaking of automation, in your opinion, are we going to lose jobs? What's going to be the impact of data science, AI, quantum computing, and all of this on the labor market?
Yeah, I don't know if I'm not an economist, so I don't know if my opinions mean a huge amount. I think that this is more of like a plea, not an expectation. But if we do this right, if we kind of take this kind of principled design-led approach of folding algorithms into human workflows and letting algorithms do things that algorithms are good at, but let humans do things that humans are good at, we could actually create more meaningful work for employees and create better products and services for the public. We could. But that means thinking more in the long term and not just kind of following what the herd is doing. What I am afraid of is that people will think more short term and just use algorithms as cost takeout. So I just saw a blue sky tweet this morning, and it was actually, it goes back to United Healthcare. I don't know if you guys heard the story, but the CEO of United Healthcare, that company I talked about earlier, was shot and killed in New York City a few weeks ago, which is just kind of a crazy story. Well, there's a newspaper writer in Albany, New York, the capital of New York State, who's writing an article about this story. And because they can't, the paper couldn't afford to hire an editor, believe it or not, they had a large language model serving as the editor. And the large language model was actually trying to correct her journalism, which is completely ridiculous. That's absurd. That is a terrible thing to use a large language model to do. It makes zero sense. Again, hence the need for more education about this kind of stuff. So that's the scenario I fear, is that people are going to hear, machine learning, artificial intelligence, we don't need humans anymore. We can no. Algorithms, here's another takeaway. Algorithms are very good at making calculations. They're very good at weighing risk factors together. They're very good at making predictions. Those are things we're hard at. But they're not good at judgment. Actually judging, is this indication appropriate to the situation at hand? Judging, is this objectionable social media content? Judging, are we covering this story wrong? That all takes professional judgment. There's actually a Greek word for this called phronesis from Aristotle. People have completely forgotten about this. But this is stuff that in computer science it's called the common sense reasoning problem. We have done all this Moore's law exponential growth in terms of the amount of transistors we can fit in a microchip and the kind of predictive power of these algorithms, the capabilities of large language models. I don't mean to minimize it. A lot of it is very, very impressive. But we've essentially made no progress on building computers that have common sense reasoning or human judgment. So that's maybe a high level way of thinking about this. You want to kind of let the computers do things that computers are good at. So be a good copy editor for that journalist. But good Lord, don't tell the journalist his or her job, because the algorithms can't judge, people can judge. So that's the difference between creating a dystopia with these technologies versus creating a better world, I think.
Hi, good afternoon. One question. So it's always not possible to give the ROI for all the automation solutions. So how to handle such solutions to get the management approval, cost approvals?
I'm sorry, my hearing is not great. Could you repeat?
So is your question around how to demonstrate the ROI for automation?
No, my point is it's always not possible to provide the ROI, to calculate the ROI for all the automation solutions.
Yeah.
So how to get the approval for such proposals?
Okay, that's a great question. Basically, the question is, it's often hard to demonstrate the ROI for data science or AI. And management, one of the big challenges for management is like, how do I go about investing in something that I don't know the ROI for?
Yes.
So what is the solution here?
I don't know if I have a solution, but again, I was lucky. I started doing this stuff before there was any hype around it. My job was 3 times more enjoyable before it was all hyped up. But think about it. Would people buy my algorithms because I'm a good-looking guy or I have a good smile? No, they wanted a value proposition. So we actually did benefit calculations, and we actually said, so this is like for a predictive algorithm. And what we basically said is, look, okay, we're going to build this algorithm. We think that it's going to have this kind of predictive power out of sample, out of time in the field. But then the crucial, if you do this with this and this with that, like if you, stop writing the worst risks or give discounts to the good risks to retain them, we're going to kind of estimate how much money you can save. And you can do a scenario analysis and just say the range will be between this and this. But the numbers were so compelling that people said, no, this actually makes economic sense to do it. But I think right now Silicon Valley right now is like the opposite. People just like throwing money at some of these, big deep learning companies with just these. I heard that Sam Altman once said, well, we don't know what our value proposition is, but once we achieve artificial general intelligence, it'll be so smart, it'll be able to figure out the value proposition for us. And it wasn't a joke. So I don't know. I think there's also just a lot of hype that short circuits smart decision making. But it is usually possible to create some kind of like a benefit. You just got to think about how are you going to fold it into the workflow. That's the question. We think the algorithm is going to have this kind of capability. I'm going to have my, whatever your metric of success is, you should be able to anticipate, if I bake it into the workflow in this way, we should be able to estimate what are the downstream benefits of it. If the doctor uses it to make these diagnoses, and we've talked with the doctors about this, and we should anticipate that it will have, this improvement in efficiency with no loss of patient safety, for example. And that's our estimate, but we'd also kind of roll it out carefully, selectively, run little controlled experiments just to make sure that our estimates were correct. Yeah, but it's usually possible to do something. Good question.
Hello. Hi, Dr. Kusha. I just have a follow-up question on what Dr. Savanan asked you on how much of the knowledge do we pass on to students in respect of data science and analysis. And that's where I feel like there is going to be a partition between the good and the bad in terms of resource constraint versus the opportunity reservoir. As a database manager, I don't know how much do I need to drill into, how many number of variables do I need to look over before analyzing a project or before assessing a project. And that's where I feel like the resource constraint is going to be on the bad side, where I don't know what limit I need to hit to, and the opportunity reservoir, where I feel like I can go into ample amount of variables and explore the opportunities into that database realm. And that's where I feel like, as a database manager, I don't know where should be my hard stop. So I wanted to hear Dr. Usha's thoughts about it.
Okay, so I think the question is around the art of model building, I suppose.
Oh.
So, I'll just reframe it as like, how do you decide what's a good model?
Excellent question. How do you decide what's a good model? Okay. Wow. It's not just a matter of predictive power, okay? I mean, I think I made that point already. There's so many different kinds of models. Let me just focus on the models used to make better decisions, right? So obviously it's got to do a better job of making predictions than the next guy. But again, does it support an improved outcome? Does it support some kind of improved process for getting a better result? Let me give you one more story, okay? Do we have time? Okay, all right. So a few years ago, maybe several years ago now, my practice was hired to build a fraud detection algorithm for a public sector agency in one of the US states. And this is unemployment insurance fraud. So the idea is, like, suppose you lose your job, you're collecting unemployment insurance benefits from the state. Every week you log onto a portal and you report how much earnings you made last week. And the amount of benefits you collect are proportionate to that. If you earn more money, you'll collect less benefits. Now, obviously there's gonna be this tendency for people to underreport their earnings. Maybe they got some cash under the table kind of thing, right? And so the state hired, and there's just a lot of this. I mean, actual intentional fraud or fraud rings is kind of a small problem relative to just a lot of people collecting a lot of, small bits of money. So it's like kind of picking up pennies off the ground. How can you do this efficiently? So our practice sold these guys a machine learning algorithm to flag people in real time who are probably collecting benefits improperly. And my colleagues called me and said, Jim, let's brainstorm how to build the best model. Like, what machine learning techniques or what ensemble of machine learning things should we build? And I was thinking snake oil. And so I said, wait a minute, guys, who sold this thing? This is not going to work. And the reason, if you're a data scientist, is like the base rate of fraud is fairly low. So even if you build a very accurate classifier, the kind of posterior probability is still going to be like medium. So like if the overall base rate is 5% of people are collecting benefits improperly, you've got this really strong model. Maybe the people in the worst decile, the worst 10% of the risks as judged by the model, maybe they have a 20 or 30% chance of collecting benefits improperly. So if you, it's a little bit like, a fraud detector for an airport security. Most of the times it's positive or false positives. The person's not really a danger. It's just that, if it's a rare thing, it's false positive, or in medical decision making too. So I was thinking about this and I thought, okay guys, bad idea to try to implement this model and use it to automatically withhold benefits. But I said, we can still salvage it. And this gets into the behavioral science. What I proposed was that we'll build the model, we'll implement it, but instead of using the model to withhold benefits improperly, it's more like hey, Shantanu, who just lost his job, did you know that 9 out of 10 of your neighbors in Bernalillo County report their earnings accurately? That's what's called a behavioral norm nudge. If you know that most people pay a tip, you tend to leave a tip too, because that's just the social norm. So it's not like some people are honest and some people are dishonest. People just kind of tend to follow what the social norms are. So if you learn, and you didn't know this, if you learn that most people actually report their earnings accurately, you feel like more of a jerk. So there's like a little bit of psychological tax you pay, you know what I mean? A little pressure to kind of report things. So we A/B tested this. We deployed this, and we tested these behavioral norm nudge messages. And what we found was that the groups that got the messages, we collected 50% more, they saved 50% of the improper benefits relative to the people that didn't get the messages. So we still use the algorithm, but in a radically different way than we sold it. We basically use this as a nudge engine. So there's a new book, you might enjoy this actually, there's a new book called AI Snake Oil, which I joke was actually the how-to manual for some companies. No, I'm kidding. It's called AI Snake Oil by a computer science professor at Princeton named Arvind Narayanan. And they talk about how a lot of predictive algorithms are snake oil. Because actually predicting a lot of social outcomes is very, very hard. Because they're just so noisy, and so many random things can happen. A bad driver might get off and not have an accident for 5 years. A good driver might have an accident the first year. A very responsible person might have a bad credit score because something exogenous happened, like whatever it is. So the trick is, if you're going to build these models, it's not like they're automatically worthless or worthwhile. But you've just got to sometimes you've got to be clever about how you operationalize them. And that can be a little bit of creativity. But in my experience, thinking about the behavioral aspects of this, that's a fruitful place to look. Sorry if that was long-winded. But.
Got it, sir. Thank you.
One last question.
Hello, Dr. James and Dean. So my question is around heuristic bias that you talked about in data. Now, as future managers, how do we identify those heuristic biases and should not let it impact our decisions, which will not be biased around under-marginalized communities? How do we how can we clean and analyze such data so that we don't make the same decisions that in past managers would have made?
So I think the question is around algorithmic biases towards maybe racial inequality or like other aspects, and how do you avoid it? Was your question specifically about avoiding it in the algorithm or from a managerial judgment as well?
Both, because one leads to the another one.
Okay.
Yeah, no, I mean, it's like, it goes back to the previous question about what makes a good model. So like, I kind of gave this kind of fancy answer, but like, you want to kind of like, going back to that design process, like when I'm the architect, or you're hiring an architect to build this house for you, you might want to say, there are going to be all these trade-offs. Like you might want a house that has like, a huge amount of space and a lot of bedrooms and a lot of natural light, but guess what? You only have this much budget. So like life is about trade-offs. It's the same thing with product design, and it's the same thing with ethics, by the way. So you might want to have a algorithm that's very highly efficient, or it is fair in one sense, but there are a lot of findings that fairness in one sense might automatically imply unfairness in another sense. So if the whole idea of fairness is actually kind of fraud. We can get into a technical conversation about it, but sometimes if an algorithm is kind of procedurally the same for two groups of people, but one group of people has that higher base rate than the others, there might actually be a higher false positive rate for one group than another group. And then if you have that different false positive rate for the minority group versus you can end up in the headlines, even though it might have been a principled decision. So again, this goes back to the need for kind of continuing education. There are these, this is like a developing science, but we're learning a lot about what causes these kinds of biases. Some is label bias, choosing a target variable that might be a little bit different than what you thought. Others might be there are fewer cases, there are fewer rows in your data set for certain protected classes, or so on and so on. Or there could just be these kind of technical trade-off issues here. And so sometimes you're going to want to get together, or even sometimes just including a variable or including a proxy variable. We used to have conversations like that, and we get the legal teams involved. We'd actually have discussions, back and forth discussions about, do we include this class of variables? Or another example, I built the first credit scoring model for a big insurance company in the US. One of the variables that goes into a credit scoring model is the number of times you've had an inquiry for a new line of credit. And this was not my decision, but somebody had the idea, don't include medical bankruptcies in that. Oh, I'm sorry, we had a bankruptcy count. Bankruptcy count, that was the variable I meant to talk about. That's very predictive of whether you're going to have an insurance claim or not. Should you even use a model like that is another fraud issue. But if you are, don't count medical bankruptcy. So all these fine-grained decisions, and this again goes back to the need for, I think, more kind of continuing education. Or at least, if you're not going to have continuing education, you want to have data scientists who can be good translators, who can explain these issues to non-technical people.
Thank you so much.
Sure. Good question.
All right, well, thank you. We are out of time now, but that was a fascinating, I got a lot of insights out of it. I think if I were to just summarize, first thing is, data science is here to stay. It is very important. I think that's the first order effect. I mean, we are not being too skeptical about it. Data science is important. Organizations have to implement data science. There's just no way around it. Now, having said that, be careful about how you go about doing it. I think one of the points that came out is keep the human or the manager. I used to think of manager, but I think this is an interesting point. Keep the team actually in mind when you make those decisions. And and as you go through it, its algorithms are subject to biases and various different issues. But I think as managers, we all need to be educated. So thank you very much, Jim, for being here and sharing your thoughts with us. Thanks.
These are good questions.